Hello everyone, in this video we'll be talking about links. What are links? In order to understand what links are, we need to understand concept of the inode. Now, the inode is that part of the operating system that stores data blocks where files are actually stored. It also stores information such as the creation, access, and modification dates, permission, file owners, and group owners of this file. In order to further explain what links are synonymous or all they behave like your aliases. While aliases, go with commands, links go with files and directories. Okay, so what this means is that for our hard links, these are names of those files. Now, we could have a situation where we had one file having more than one name, and whatever we do will still refer to that same inode, that same data block. So wherever we try to access the file, we can get it. However, hard links can only be used for files and not directories. Further down the line, we'll look at another kind of link that can be used for directories. But for now, let's take a look at what the hard links look like in the terminal. In the terminal, let's take, for instance, let's do an ls on our home directory. Doing an ls on our home directory, we see a file called new. Okay, so let's just see what kind of file this is. In order to see what kind of file it is, we're just going to say file and then new, and then we see it's a text file, ASCII text. Okay, so and let's create a link for this file on our desktop. So the way it works, all that we need to specify is ln, the file we're trying to work with, and then where the link is supposed to be, or the name of the link. Okay, so let's call this link, and then or link underscore new, and then what are we trying sorry, the file name is new, and then the link is that. So we have this, but do we want to put it in the same directory? Nah, let's put it in the on desktop. So we'll just have desktop. Since we can specify a relative path from here, we'll specify the relative path saying that we're going to put the new link on the desktop. Now this is a hard link, which means that it is the same as the new. So basically our new file will have two file names. One is link underscore new and the other is new. Okay, so once we do that, we can change directory to our desktop and then do an ls looking for link underscore new, and it shows us our file, and then we see our link here. Now let's add some text to first. Let's cut the new we have here to see whether it has some text in it. Okay, so let's do a cut going up by 1. We want to see new up by 1 directory, and this no longer contains the error, is the text that is contained inside that file. Okay, so in our link underscore new, let's redirect a string of this is CentOS, and append it to link new, link underscore new, and we press enter. Now we are on the desktop where link underscore new is. So if we cat link underscore new, what we should get is this no longer contains the error, as well as this is CentOS as the second line, because we appended that echo, okay, to our link underscore new. Okay. Excuse me. So basically, let's do the cat on this link underscore new, and what do we get? This no longer contains the error. This is CentOS. And of course, if we do a file for our link underscore new, it shows us that it's also an ASCII text. Now, what happens if we delete the original file? Now, if we want to delete the original file, we'll do an rm of going up one directory and new, okay, and then we delete that. Now let's see if we still have our link underscore new. So we do an ls-l for link underscore new, and yes, we still have it, but are the contents still there? And we check if the contents are intact, and the contents are intact. However, so essentially what this means is we only deleted one of the names this file bears, because it is a hard link. Just like the diagram that I showed earlier, you can have multiple hard links. You have multiple hard links referring to a particular inode, which refers to a particular data block or specified data blocks. You see, so that's what hard links are. However, there are other kinds of links, also referred to as soft links or symbolic links. Okay, so what are soft links? Soft links are similar to your shortcuts in the GUI. They point to hard links. They don't exist in of themselves. So let's take an instance of a soft link, and soft links in this case can also be created for directories. So if you do, okay, let's just take an instance in the terminal. So let's take an instance of the symbolic link creation on a directory. Now let's say, for instance, we want to create a symbolic link in our /temp folder of the symbolic link of the desktop on our /temp folder. Okay, so in order to do that, let's say we were in our home directory. In order to do that, we'll say we are creating a symbolic link by using the option S, and we'll specify our source, in this case of our directory. The directory we want to create the link for is our home directory. Our desktop, which is in our home directory. So this, and where do we want to put this? We want to put it in /temp. So we just simply specify /temp. If we specified anything other than /temp and typed anything here that does not exist, then it will create a file and not a symbolic link directory. Okay, so Otherwise, if we wanted to use a file, I mean, sorry, a directory inside our temp directory, that is a subdirectory of the temp directory, we would have to do a make dir for that directory. Okay, so but in this case, let's just continue with this and then we'll see an instance of doing that as well. Okay, so we do an ln for our desktop, and we simply just press enter and the symbolic link should have been created. Now if we do an ls of /temp/tmp, we should see somewhere here the link we just created. Okay, so we see that desktop is now here, which links to our /home/orelua/desktop. So it means that if we cd into that particular directory and then we do an ls of desktop, we see the contents of our desktop. Now let's just also do an ls of our desktop from the home directory. We see that it is equivalent. Now note that we are in temp as our present working directory, and if we do an ls for our link, we get these files. Now if we do an ls of the home directory desktop, we also get the same files, showing that the link actually does work. So whatever we do here in this shortcut in /temp will be reflected here in the main one. However, if we do a remove, we can easily remove our link by doing an rm and removing the desktop link. But if we and once we do that, it deletes the link. Now let's create the link again, this time doing a, you remember that when we want to if we let's confirm that it has been deleted first before we go any further. Okay, so if we scroll up just a little more, okay, so if we scroll, we see what's okay, remove desktop, and then we do an ls. If we look here, we do not see desktop anymore, which is what we removed. Okay, so and if we continue to scroll down, we see that it's not there. Okay, so we are sure that we have removed it. Now if we created that link again by just running that command again, and instead of removing it just by doing rm, we used the option that we used for our directories, recursive, and then forcefully doing it as r and f. If we did that, we will get, what we will get is I'm sorry, slash not slash, since we're in the tmp directory already, all that we need to specify is the link. And to specify the link, we do desktop and press enter. Now if we check, we would see that we no longer have desktop here, but something else has also happened. Now if we check, we'll see that our desktop is still present. Now let's also check what has happened with the one at the home directory. So we do a slash, we do a cd to go back home, and we do an ls-l, and we do a cd into our desktop, an ls of our desktop, and then we see that the contents of our desktop is gone. So if we do a recursive remove of a link, it deletes the content of the content of the link, and does not even delete the link, neither does it delete the linked directory, but it deletes the content of those directories, of the hard link. Deletes the contents of the hard link and does not delete the link. So if, for instance, we went back into our /temp and then we say we also did a cd into the link we have here, and then we created a file if we left here for home and then came back to our desktop, we cd into the desktop under the home directory and did an ls, we'll see file 1. Okay, but every other thing that we had on our desktop was deleted, but the link still works. The what's it called now, the hard link is still present. Okay, so this is what happens when you do a recursive remove on a link. However, of course, if I did a recursive remove on the hard directory, say for instance I did on the hard link, I did this, and I did a remove on my desktop under home, and I did a recursive so that it can delete the directory, and I did desktop. Now this is the hard link, and I press enter. Now if I do an ls of my home directory, we would see that I no longer have a desktop. Now what would happen to the soft link that we have? Now let's see what happens to the soft link we have. We have a soft link under /temp. So I'm just going to do a cd to /tmp/desktop. Now no file or directory because the hard link is gone. Okay, so let's just be sure of that. So we cd into /temp, and then we do an ls-l of desktop, and even though the link is here, but because the hard link no longer exists, this has become useless because it points to an invalid hard link. So if you try, and that's why we got no file or directory, because if we tried to change directory into desktop again, sorry, well, specify that was specifying the full path, but I could have just specified the relative path and then did this, and then it says no directory. Now let's open a new terminal and recreate this the desktop in our home directory, and then try this command again and then see what happens. So we'll open a new terminal, and in this terminal we are going to go to our home directory and then make a new directory, and the name of the directory shall be called desktop, and we press enter. And if we try to do a cd to desktop on using this link, the link now works because the directory now exists. Okay, so once a hard link is deleted, it invalidates the soft link. Okay, and that's just what I've been able to show you here. Now, so these are, of course, soft links can also be made for files, just like you have for directories, and the same thing applies. Once the hard link is deleted, it invalidates the soft link, because soft links are essentially shortcuts to hard links. However, for files, you can have more than one hard link pointing to an inode which points to data blocks. Okay, so this is the relationship between soft links, hard links, and inodes and data blocks.